Well, folks, today we'll be looking at the sine rule. Good morning, good afternoon, good day, whatever time that you are actually watching this particular video. It is me again, Mr. Matleviani, your mathematics educator. Sine rule is one of the important rules in mathematics, in the section of trigonometry. But before I start, please, if you are new to my channel, subscribe, like, share, and don't forget to hit the notification button. So without any waste of time, let's get into the sine rule. The sine rule says, let's say you are given the following. You are given a triangle, and this triangle is triangle ABC. I'll use different colors so that you understand it better. You see, you are saying triangle ABC. ABC are actually your vertices of the triangle. So you are supposed to prove that sine A divided by A is equals to sine B divided by B, which is equals to sine C divided by C. Okay. Now I'm going to explain how you can easily remember this the sine rule. Now let's have our triangle. You are given triangle ABC. And let's remember how we actually label the sides of our triangle. We know very well that the side that is opposite to angle A, it will be small letter A. Okay, and the side that is opposite to angle C, it will be small letter C, and the side opposite to B, it will be small letter B. So in simple terms, sine rule says the sine of an angle divided by the side that is opposite to that angle is equals to the sine of another angle opposite to. So it's a ratio of sine and angle and the side opposite to that particular angle. Okay, so in an examination you can't be asked to prove all these ratios at once. So examiner might say prove that sine A divided by A is equals to sine B divided by B, or prove that sine A divided by A is equals to sine C divided by C, or lastly, it can be sine B divided by B is equals to sine C divided by C. So now, your triangle, or whatever you are proving here, your triangle is actually guided or dictated by what you are supposed to prove. If you are supposed to prove that sine A divided by A is equals to sine B divided by B, then it means the vertices in the standard position. So the vertices in your horizontal plane, it will actually be A and C. I mean A and B. But if we are supposed to, like in this triangle, this is a triangle that we can use to prove that sine A divided by A is equals to sine C divided by C, because A and C, these two angles or these vertices, they are vertices in the standard position. Okay, so if I take B and put it here, then A and B will be in a standard position. It means I'll be proving the two. But if I take B and C, it means I'll be proving sine B divided by B is equals to sine C divided by C. So you must first check what is it that you are actually asked to do. Okay, so the angles that you are having here are the ones that will actually tell you which vertices are supposed to be in a standard position. And when I'm saying in a standard position, it means they are in the same horizontal plane per se. So now, we are supposed to prove, we are given this triangle, we are supposed to prove that sine A. So in this case, it means we will be able to prove that sine A divided by A is equals to sine C divided by C. And the same way that we're going to prove that sine A divided by A is equals to sine C divided by C will be the same way that we can actually prove any other ratio, depending on which vertices are actually in a standard position. Okay, let's understand it from that point. Now, let's hop into it. So it means, like I've already indicated, those are the sides. Those are the sides, C opposite to C, A opposite to, just like that. So it means this is side AC, or you can call it small letter B. This is side AB, or you can call it small letter C. And then this is side BC, you can call it small letter A. All right. Now let's look at a proof. A proof means the steps that you are going to follow until you reach the final point. Okay. So the first thing that we are supposed to do is we have to construct. And let's understand that a construction is actually the information that you put on the diagram that was not given. But that particular information is needed for you in order to prove. You got my point? So it is the information that was not there, but it is necessary for us to have it in order for us to be able to prove the sine rule. So when you say I am constructing, you're trying to say the information was not given, but I need this information in order for me to prove. That is why when you construct, you should actually draw your lines with broken lines to show that this is a construction. So with this one, we'll actually start by construction. You will actually construct BD. Obviously, we need a particular point here which we'll call BD, but it must be perpendicular to AC. When you say two lines are perpendicular to one another, it means at the point of intersection they form a right angle like this one. Okay, so it means this line that we have actually constructed, which I can actually call BD, it's perpendicular to AC. That is why they are forming an angle of 90 degrees at the point of intersection. And in this case, our point of intersection is D. So let's call that particular height, because it will be the height. Height is drawn from the apex. Apex is the top vertex. Okay, it's drawn from the apex to the base of the triangle. So it means in this case we have constructed the altitude, or we have constructed the height H, which we call BD, which is supposed to be perpendicular to DC. Why are we doing it in this way? Because we are proving two ratios, so we must have two triangles. So immediately when you drop a perpendicular, then it means our triangle ABC, which was not a right angle, is now divided into two right angles. Okay, which is right angle ABD and right angle BCD. Okay, ABD qualifies to be a right angle because if this is 90, this is also 90. You remember very well straight angles on a straight line, they form 180 degrees. So what we're going to do is we're going to be looking into these two triangles that we have actually created now. We'll start with triangle BCD, and then from there we talk about triangle ABD using the trigonometric ratios. Okay, so our first step will be, you must indicate which triangles are you going to be dealing with, because we are actually having three triangles here. Somebody might not be seeing it. Okay, you have triangle ABD, you also have triangle CBD. It is important when you name them, like you're starting from outside, you go to the apex. From outside, you go to the apex. You see ABD, CBD. That is orderly. Okay, so we're going to be looking into these two triangles. Then what is it that we see in these two triangles? One, we actually see that in triangle ABD, okay, if angle A is our reference angle, it means we know two sides, and one of the sides that we know is H, and then we also know C. And remember, C is actually the hypotenuse of triangle ABD, since this angle is 90 and hypotenuse is always opposite to a right angle. Okay, so it means we actually have the relationship between angle A, which is our reference, and this side, which is H, is that it is opposite. Okay, and then C is the hypotenuse. So we check which trigonometric ratio talks about the opposite and hypotenuse, and that is sine. That is why we say sine A is equals to H divided by C. Then from here, what we're going to do is you just cross multiply once. so that we make h the subject of the formula. Or if you don't cross multiply once, you can multiply both sides by c. Then you end up having h is equals to c sine a, and then we'll name that equation number 1. Okay, so it means we are actually expressing h in terms of sine and the hypotenuse. Okay, then now we'll continue, and then we'll say in triangle B CBD, which we have already indicated here. Now we're going to look at that angle in the standard position. It means we are actually focusing on angles in the standard position as a reference angle. So if that is the case, so the same thing apply here. Okay, we actually have what? The side that is opposite to C, which is our reference angle, and A is the hypotenuse. So the trigonometric ratio that deals with opposite and hypotenuse is still sine. Therefore, it means sine is equals to opposite, and our opposite side is h divided by the hypotenuse. You get it? So that is why we have sine C, angle C is equals to h divided by A. Okay. Then you continue. You make h the subject of the formula. It means we are actually expressing h in terms of hypotenuse and the sine of the angle in the standard position. So whatever you did here in this triangle ABD, you also do in triangle CBD. So now let's check equation number 1, equation number 2. The expressions on the right hand side, C sine A and A sine C, they are all equals to the same variable, which is A. So mathematically and ideally and logically, if both expressions are equals to the same variable, it means they are also equal. Okay, because h is equals to h, it means C sine A is equals to A sine C. Okay, then we can actually write it nicely to say this will actually imply that C sine A is equals to A sine C. But every time when you prove, you must check what you are supposed to be proving here. Okay, right now let's check. We need the sine A in the numerator. We have sine A in the numerator. We need sine C in the numerator. We have sine C in the numerator. So what is it that we're supposed to remove? We need to remove the C, the side C, okay, and A. Therefore, it means we can't divide by C only. If we divide by C only, then A will remain on the right-hand side. If we divide by A only, then C will remain on the left-hand side. So it means we must divide by the product of the two sides. So we are going to divide through by AC, so that in the numerator we remain with trigonometric functions only. You get my point? Now, if you divide the left-hand side and the right-hand side with AC, then you remain with C sine A divided by AC is equals to A sine C divided by AC. Then automatically your C and C will divide, and then your A and A will divide. Then you remain with sine A divided by A, small letter a, is equals to sine C divided by small letter c. Then we have proven the ratio. We have proven the sine rule for this ratio of sine A divided by A and sine C divided by C. Like I said, because we are still in mathematics, is allowed to say if you are going to repeat the same process in order to prove that sine A divided by sine B, sine A divided by A is equals to sine B divided by B, you can easily say similarly. Similarly means in the same way that I did with sine A divided by A is equals to sine C divided by B, I can still do sine B divided by B with sine C divided by C, or sine angle A divided by A with sine angle B divided by B. Okay, and I said you check the ratios every time. You check, if we were to look at this one, sine A divided by A and sine B divided by B, then our angle in the standard position, it will be A and B. So people, it's allowed. In the same way, you just say similarly, it can be proven that all these ratios are actually equal. Okay, and then now logic allows. It allows that when you have a fraction which is equal to another fraction, you can still write it in the opposite way. If the numerators become, if you take the reciprocal of this particular ratio, then it will still be valid. Mathematically, it will still be valid. So somebody that writes sine A divided by A is equals to sine B divided by B, which is equals to sine C divided by C, this will be the same as A divided by sine A, which is equals to B divided by sine B, which is equals to C divided by sine C. Okay, so these two things, this one is implied by this one. Okay, so they are the same. They are the same in all respect. Okay, so it means even if you were actually asked to prove that A sine A is equals to C divided by sine C, and then you arrive at this point, then you can easily conclude and say, therefore, this is the same as A divided by sine A is equals to C divided by sine C. So this is the sine rule in both ways, and then it's the same, and then it is valid. Okay, and then we'll be in the next video, we'll be looking at the application of the sine rule to say when can one actually apply the sine rule, and then how does it actually help us. You get my point? All right, now thank you very much. People, subscribe, like, and share, and as usual, don't forget to hit the notification button so that you are notified of future videos. Thank you for watching, and please don't forget to subscribe and leave comments below, and I'll also leave the links for other videos that I've already uploaded. Okay, I'll also leave links for the materials, the question papers materials that I normally take questions from as examples. Okay, thank you very much, and God bless.